We can find a unit vector that's in the direction of a given vector by using a pretty simplistic formula. So remember, we defined a unit vector to be any vector of magnitude 1, right? And so if we want to try to find a unit vector in the direction of a given vector, that's going to be 1 over the magnitude times the vector, or the vector v divided by the magnitude of the vector. So if we want to try to find a unit vector in the direction of the given vector, first we're going to find the magnitude of v. Okay, so the magnitude of v is going to be equal to the square root of 2 squared plus 3 squared. All right, and we can clearly see that's going to be equal to 13. Okay, so it'll be 4 plus 9. And so we could just take 1 over root 13 and just multiply it by 2 comma 3, okay, in the component form. And so we could write this as 2 over root 13 comma 3 over root 13. And so this would be a unit vector in the direction of 2 comma 3. Now, just to show you how to check this, okay, that it's a unit vector, we could just take and find the magnitude of this by finding 2 over root 13 square. Okay, that should be a 13 under the radical, plus 3 over root 13 squared. Right? And just to show you that this is a unit vector, we know that 2 squared is 4, and we know that 13 under a radical squared is 13. 3 squared is 9, and then again 13. And so this ends up being the square root of 13 over 13, which is root 1, which is 1. All right, so that's how, if you really wanted to check this, that's how you would do it, okay, just to verify that it is a unit vector in the direction. 4i minus 5j. So let's first of all find the magnitude of vector w. And so that's going to be 4 squared plus negative 20, or negative 5 squared, excuse me. I'll just jump to 25. Okay, and so we know that that's going to be 16 plus 25, which is the square root of 41. And then we could just take the square root of 41 and multiply it, or 1 over 41. So we would just take 1 over the square root of 41 and multiply that by 4i minus 5j. And so the unit vector in the same direction would be 4 over root 41i minus 5 over root 41j. Okay, so that's all you have to do to find a unit vector in the same direction. Now, consequently, what if we wanted to try to find a vector of a different magnitude in the same direction? So, for instance, magnitude 3 in the direction of 2, negative 1. So what we would do first is we would find a unit vector. Then what we would do is we would just multiply by the magnitude, okay? Because remember, multiplying by a scalar just says that we're going to change the magnitude of that. So then we multiply by the given magnitude. All right, so let's say, for instance, we had this vector, 2, negative 1. We find the magnitude of u, which is going to be equal to the square root of 2 squared plus negative 1 squared, which is going to be the square root of 5. And so the unit vector in that direction would be 2 over root 5, comma, negative 1 over root 5. Okay? But if I wanted it to have magnitude 3, then what I would do is I would just multiply that vector by 3. So root 3, or 3 over 2 roots of 5, comma, negative 1 over square root of 5, or that would be 6 over square root of 5, comma, negative 3 over square root of 5. Okay, and that would be our vector of magnitude 3 in that direction. Okay, so of course you can use that trick that I just showed you if you don't believe me, and you could see that it'll have a magnitude of 3 as we go through. Okay, and just go through and try to find the magnitude of this vector. If I wanted to shrink the vector, so if I wanted to make the magnitude a third in the direction of negative 1i, or negative I, negative, or negative 4, then first I would find the magnitude of u, okay, and that's going to be the square root of negative 1 square plus negative 4 square. which is square root of 17, if we just compute that out. And so if we wanted a unit vector in the same direction of u, that would be negative 1 over root 17I minus 4 over root 17j. All right. But what we want is we want a vector of magnitude. Let me make that look like the word magnitude somehow. We would multiply that by 1/3. Okay, so if I wanted a magnitude of 1/3, not 1/2, 1/3, then what I would do is I would just multiply this vector by a third. Okay, so I would have 1/3 of negative 1 over root 17I minus 4 over root 17j. Right? And so that would be equal to negative 1 over 3 roots of 17I minus 1 over, or excuse me, 4 over 3 roots of 17j. Okay, and that would be a vector of magnitude 1/3 in this direction. Okay, so now you always have to find the unit vector first. And once you find that, then you can multiply by the scalar because that'll have because initially it has magnitude 1. Then whenever you multiply by the scalar, then it either shrinks or contracts. Okay. All right, so in our next video, we're going to take a look at these direction angles. Okay, we're getting close to being done with these elementary sorts of vectors, but it might be a good time for you to go back because we are going through a lot of operations that are simplistic, but make sure that you can do all the computations for these and you understand the concepts. So for instance, if I asked you to be able to find the magnitude, or if I asked you to be able to, let's say, find 3u minus 4j or something like that, that you can do those sorts of operations before we move on.